All right, so the overarching concept that we are beginning is conic sections, all right, meaning sections of a cone. And so in geometry, when we talked about cones, I showed you these. We even talked about what conic sections were. We didn't really go any farther than this is what they are. I think we did graph some on the calculator, but you didn't really necessarily know what the things were. But to get conic sections, you can have something that's called a double cone like this. You don't need it for all of them, but if you take a plane and it slices through the cone, it creates cross sections that become our conic sections. So the first one we're going to look at is a circle. So if I take a plane and it goes parallel to the base of the cone at any level, it doesn't just have to be up here, then the cross section you get is a circle. Okay. The other one that you have talked about so far already mathematically is the one that goes diagonally through the cone and intersects the base so that you get this. I can do it without dropping it maybe. Which would be a what? What have you graphed? Parabola. Okay, so this is a parabola because it's curved right here. I'm probably not holding it very well. It's curved because it comes off that cone, and then what you have there is a parabola. Okay, so parabolas you've looked at, you may not have used the words conic section with it, but it is a conic section, and then circles are conic sections as well. Now, the beginning part of these notes, I've pretty much taken from what we learn in geometry, but I always figure out after we do equations of circles in geometry, like everybody gets it, and I feel like everybody gets it. We just do activity, and like a month later, I bring it up again, and it's an equation, and everybody's like, I have no idea what that is. I've never seen it before in my life. So clearly, it's not going to hurt to do this again, because you need to be able to make these connections. All right, so first thing is the definition, because I think wording is important, especially when y'all are getting closer to college and you're going to have to teach yourselves more than you realize you are. Okay, even when you have fantastic professors, you got to be able to look through stuff and read through textbooks that may even be mathematically based textbooks that you're not used to reading, and you got to let the wording not freak you out. So first definition is the definition of a circle, so it's not really even that crazy of a definition. But this is one way to phrase the definition. A circle is a locus of points. Okay, so that phrasing you have heard before, because you heard it from me. I don't know if you used it necessarily in Algebra 2 at all. I could have changed it and made it better wording, but again, you need to hear these words. Anybody know what a locus of points means? A lot. Kind of. Huh? A bunch of points. Kind of. It's not, though, the locust. There's not a T on it. It's not the bug that makes a lot of noise and leaves its skin on your tree. Y'all know what a locust is? They're also, I think, cicadas. I don't know if they're the same thing or not, but that's not what this is. Locus. All this means, all the locuses, this just means a set of points. So when we start looking at different sets of points for different things, when we're maybe just looking at sets of numbers, and we talk about a locus of points. And there's different words for that, but again, I wanted you to hear the word. Okay, so a locus of points in a plane, that's important. That means it's two-dimensional, that are a fixed distance, called the radius, from a fixed point called the center. Okay. So it's a set of all points in a plane, the same distance from the center. So if the end of my pen is the center, right, and then we're going to stay two-dimensionally, so like in this plane right here, when it goes like this, basically I end up drawing the circle. That's where your set of all points is just the outside part of it. Okay, so the equation of a circle is based on the distance formula and the fact that all points in a circle are equidistant from the center. Now, the center point of a circle, what letters make up the center point? Do you remember? H and K. Very good. H and K. And then we'll make this point right here some random point on the circle, which we'll call point XY. And then this is my radius, R. So the distance formula looks like this. Now remember, if you need the distance formula for anything, you can use Pythagorean theorem. I mean, it works for you to figure things out. But when you're trying to build it, really, hopefully you're starting to learn how to think of things conceptually instead of memorizing formulas. The distance formula has a ginormous square root, right? Yes, we agree with that. So there's a big old square root. And then it comes from the Pythagorean theorem. So it's something squared plus something squared, right? Since we're adding in between them, it's subtraction that's in here. And do we mix x and y? We don't ever mix x and y, right? So then it's just x2 minus x1 and y2 minus y1. Right? So that's a way to build it without just trying to have it memorized. If you memorize it and you understand formulas, that's great. Not everybody's brain works that way. But we're going to use the distance formula with this to come up with our circle equation, which we already know and we've talked about multiple times, but I want you to remember where it's coming from here. So the distance here is actually r. That's equal to, if I do x2 minus x1, that's x minus h squared plus, and then y minus k squared. That's where it's coming from. But I want to leave the yucky square root in there, so square both sides, and r squared is equal to x minus h squared plus y minus k squared. Now, conic sections used to be taught in Algebra 2, and they're not anymore. So I know that y'all don't go deep into all of this. Did you do circles at all in Algebra 2? Do you remember? I'm thinking the answer is no now, but I've asked Ms. McWhorter a couple times, but now I'm confused as to what's old and what's new and whatever. It's okay. I mean, you did learn this because you learned in geometry, but so the equation of a circle with center HK and radius r is x minus h squared plus y minus k squared equals r squared. Think Pythagorean theorem, so you know it's squared plus squared equals squared. And then there's addition in the middle, so there's subtraction here. Fairly simple, okay? We all good? Notice there's no coefficient in front of x and y, and there's not going to be at any point for a circle. Right? So this is the standard form, right? Standard form equation. The general form equation of a circle is a form of the general form equation for any conic, but I'm not going to give you just the conic one here. I think it might confuse things. Basically, that means if I take this and I multiply it all out, right? So it's multiplied all out. Come on, I'm going to make you stand up in the back of the room. Right. If I multiply it all out, I'm going to kind of take the h and the k's out of it. We're not going to work through it, but it's the form that doesn't look like this that would give us the center and the radius. Looks like this, x squared plus y squared. All right, so then we're going to use some letters that it seems strange that we start where we do, but that's because we use it. It looks a little bit different for other conics. Then plus capital D times x plus e times y plus f equals 0. And D, E, and F just represent numbers, okay? But x and y, notice they don't have coefficients in front of them. That's important. And this order is important. So you've got the x to the second, y to the second, x to the first, y to the first, and then no variable at all. And of course, some of these terms, one or more of these terms right here could be missing depending on what's happening. Okay? We good with that? And it's okay, like this is important that you understand it with the h and the k. This right here with the letters, not so much. Just know that the general form has to be multiplied all out, and that it has to be like in that order as far as your exponents go, and you'll be fine. All right, so we're going to graph each circle, and we're going to state the center and the radius of the circle. So when I look at this, if this is really x minus h squared plus y minus k squared equals r squared, right? So for this circle here, what's the center point? -2, 5. Good. -2, 5, because there's that minus in there. Don't forget about that. And then what's the radius? 3. Okay. So then I can go and plot this. I'm going to go to -2, 1, 2, 3, 4, 5. Make my point, and I'm going to label it as the center. I mean, it doesn't really say that, and it's not the end of the world if you don't, but it's also easy to kind of mess up on something simple if you don't do that. So from here, I can't count diagonally, but I can go to the right 3 and go back to C, and go up 3, go back to the center, go left 3, back to the center, go down 3. Then you just do your best to make it look circular without it making it look like just don't connect the dots and make it look like a square. It doesn't have to be a dotted line, but I can usually do a little bit better job if mine's dotted. It's still not great by any means, but it's actually not bad for the first one of the day. Everybody okay with that? All right. So on B, before we graph it, what do we need to do? Okay, factor. And I like that you said factor and don't just divide it out. Now here's the difference. If you have a if you have a quadratic that you're going to go and graph and you're supposed to factor out the GCF, if you actually just divide through by everything, that's a really bad thing, right? Well, here, the center and the radius is what it is. So regardless of whether or not I just factor out that 4 or I divide everything through by 4, the center and the radius is the same. Okay, so you have a kind of a little bit of a different rule. And so I can factor it out. And then when I factor it out, I would end up dividing anyway. So if I just, you can think of it as factoring it out like this. But again, as long as you divide every single term by 4, you wouldn't necessarily have to factor first. So if I divide it all out, I get x squared plus y squared equals what? 32. Good. So the center is what? 0, 0. Good. So I'm going to go ahead and plot that and make that my center point. What's the radius? Square root of 32, right? And then I would like to simplify that. Can I simplify that? 4 square root of 2. Good, because that's 16 times 2, so it's really 4 square root of 2. Now, this would be my answer, these two things right here. But I need a number that I can actually go and find on the graph kind of decently. So remember, square root of 2 is about how much? 1.4. That's a good estimate to have in your head, right? I mean, obviously, if I wanted it exact, I'm not going to estimate with this number. So if I do 4 times 1.4, so that's 2 times 1.4 is 2.8, and then 2.8 times 2 is 5.6. Okay, so that's about 5.6. Notice it's not really my answer. Okay, that's just kind of for me to be able to go find something to plot. So my radius is about 5.6. So 1, 2, 3, 4, 5, about 5.6, and then just do that from the center each time. These are the only two we're going to graph on the notes, but on the homework it asks you to graph a lot of them. But honestly, if you can graph one of them, you can graph all of them. All you got to be able to do is find the center and the radius, and you're totally capable of that. Okay, we good? Any questions? Awesome. All right, so now we're going to use the given information to write the equation of each circle in standard form. For C and D, we're also going to write in general form. All right, so first of all, standard form is x minus h squared plus y minus k squared equals r squared. If you don't already know that and are comfortable with, I just know that that's the equation of a circle, then I highly suggest you write that down every single time you have to do it. Because if you do that, then by the time you're done, you'll know what it is without memorizing it. And then if you need to, you can label h and k, and this is r. So then I'm going to go substitute this in. It's going to be x minus 4 squared plus y minus a negative 2 squared equals 6 squared. All I did was substitute. So then you clean it up. But remember, pay attention to how you're supposed to have your answer. This says in standard form. This is standard form. So when I clean it up, I can't clean it up too much. I don't want to actually multiply that out. That stays x minus 4. But what does this become? Y plus 2. And then that equals what? 36. Everybody okay with that? Okay. So here on this one, go ahead and write it out again. X minus h squared plus y minus k squared equals r squared. So that's going to give me x minus 0 squared plus y minus 3 squared equals 2 square root of 3 squared. What is 2 square root of 3 squared? 12. And what should I really have when I wrote that down? Parentheses. Okay, now if you do this and you know what you mean, that's one thing. Sometimes you don't even know what you mean when you write things down, or then you go and use the calculator and you use it wrong and it gives you the wrong answer. Okay, because if you get 6, that's just not the right answer. Well, what's x minus 0 squared? X squared. So x squared plus y minus 3 squared equals 12, right? Because I got to square the 2 and square the square root of 3. There is my answer in standard form. Everybody good? Yes? All right, so now C says we have the center at -6, -3, and it passes through this point. So they gave me the center, they didn't give me the radius. Well, the center I know is at HK. A point on the circle, what would that be? XY. So if I write this down again, x minus h squared plus y minus k squared equals r squared. So I need r. Can I find it? Yes. What do? Plug it all in. So this is going to give me x, which is -2, minus h, which is a -6 squared, plus y, which is 6, minus k, which is 3 squared, equals r squared. So -2 minus a -6 is actually plus a positive, so this becomes 4 squared. What's 4 squared? 16. Plus this would be 3 squared, which is 9. That's equal to r squared. So r squared equals 25, and r equals what? 5. Now, the most mistakes on things like this are made by careless errors, right? You plugging in the wrong numbers, not paying attention. It's not that you don't understand it. So when you do this, and I need to go back and write my equation, which one of these two ordered pairs am I actually using to write my equation? HK. So I'm going to circle that one, and I'm going to mark that one out. I needed it. It helped me a lot. I am done with it. Don't go use it as the center or try and plug it all in, because then that makes absolutely no sense. So then I get x minus a -6 squared plus y minus 3 squared equals 5 squared. So x plus 6 squared plus y minus 3 squared equals 25. Everybody okay with all that so far? Now it said in standard form, and then it also said for C and D, also write in general form. That means I have to stop here and bam, that is my answer. And then I got to keep going and get it in general form. So I need to square this out. So this would give me x squared plus what? 12x. Well, yeah, but I think I might get confused if I try and do it at the same time. X squared plus 12x plus 36. Plus y squared, then what? Minus 6y plus 9 equals 25 still. Okay. So I've multiplied it all out. Now I've just got to actually put it in general form. General form doesn't just mean multiplied out. I've got to get it in the right order. So then it does become x squared plus y squared. And the next term should be x to the first power. If I have one, it's possible that you don't have one, but I do have one. So plus 12x, and then minus 6y. And then don't lose track of what you have in here, because it's got to equal 0. So we got to take this 36 and the 9, which is what? 45. And then I got to move the 25 over, so I subtract that, and so I get plus 20 equals 0. That is your general form. Okay. Standard form, general form. Everybody good with all that? Yes? Any questions? You'll never have any questions. Okay. So now here I'm going to do the same thing, but they didn't give me the center and a point on the circle. They gave me the center, so this is HK. But it tells me that it's tangent to the y-axis. So all you got to do is sketch yourself a little picture to make sure you wrap your mind around it. Dang it. Thank you. Hopefully I said HK. But, okay, good. I just didn't write HK. That helps. All right. Thank you, though. So I'm going to sketch myself a little picture. I'm not even going to worry about it being super accurate. I just got to wrap my mind around what's happening. If my center is at -611, so it's like here somewhere, right? And it's tangent to the y-axis. Make sure you get the correct axis in your mind, too. This is my y-axis. So my circle would be something like that. If I know that much, what's the radius? Yeah, the distance between. So it's basically my x distance, which is 6. Okay, so if you just sketch yourself, that way you can make sure that you're using the right one. So now I know that the radius is 6. So if this is x minus h squared plus y minus k squared equals r squared. Once you get the hang of it, I don't think you need to like substitute and then fix. I think you kind of do it all at once as long as you're not messing up. X minus h would just be x plus 6 squared plus y minus 11 squared equals what? 36. So this is my standard form, right? Then go ahead and multiply it out and get your general form. I totally just did the wrong thing now. I realized when I was looked at my answer, I was like, that's not right. All right, so here's what I did, and don't ask me why I used that. Well, I know what I did. I used that as 1 instead of 11. So hopefully you don't agree with me, because if you do agree with me, that's a little scary, because I don't even know where your brain, how yours matches mine. Yeah, I used that as a 1 both times. Like, I didn't use it as an 11, even though clearly it's an 11. So let me fix mine, and then we'll see if we agree. I was like, well, that does not look right. Okay. So y squared minus 22y plus 121 equals 36. There you go. That makes a whole lot more sense, right? Okay, so then that gives me x squared plus y squared plus 12x minus 22y. Then the 36, when I subtract that over, that goes away. So this is just plus 121 equals 0. Do y'all agree with that one? That's one you should agree with. Good. All right, any questions at all? We good with that? Awesome. All right, so the next one says, write an equation in standard form, find the coordinates of the center, the radius, and any intercepts of each circle. All right, so we have it in general form. I want it in standard form. So basically I've got to undo what we just did. And that means I need to take these and get them into binomials that are squared. Well, it's likely that I don't necessarily have it exactly perfect and beautiful like I would like, but I want to start off first by going to isolate and group. Isolate and group. So I need to at least group things together, right? So that means I'm going to take my x squared, and it's got to go with my x, right? And then my y squared has got to go with my y. And then this, the constant, I'm going to move over here. Now, how can I get this into something that would be useful for me to actually get these as binomial squares? Completing the square, exactly. So I'm going to rewrite this as x squared minus 6x plus, I'm going to leave a blank, plus y squared plus 4y plus, I'm going to leave a blank, equals 12. So when I go back over here, if I'm going to complete the square, what goes here? What number? 9, because I take half of the 6 and I square it and I get 9. So if I add 9 here, I got to add 9 over here. Then what goes here? 4. And not because it matches this, but because half of 4 is 2 and you square it and you get 4. So if I add it here, I got to add it here. Right? That's completing the square. Not very difficult, especially when a is 1. Here, we're good. Okay, so then this becomes x what? What goes in here? Minus 3 squared, good, plus y plus 2 squared equals, what's 12 plus 9 plus 4? 25. Okay. So here I have written it in standard form. It also says find the coordinates of the center, the radius, and any intercepts of each circle. So the center, what's the center point? 3, -2. And the radius is 5. Okay? So there's the center and the radius. Now I need to find the intercepts, right? How many intercepts are possible with a circle? How many X and Y-intercepts altogether? Think about that. 4. I could have 4, right? Could I have 0? Yeah. Could I have 1? Yes, if it's tangent to just one of the axes. Could I have 2? Yes. Could I have 3? Yeah. So you could have like lots of different things, right? All right. So let's look at how to find that. If I want to start and find the X-intercepts, how do I find the X-intercept? What does it mean? X-intercept is put the 0 in for Y, right? The X-intercept is when 0 equals Y. So I'm going to put a 0 in for Y right here and start with my X's first. So if I put a 0 in for Y, this remains X minus 3 squared plus, well, 0 in here for Y. That's going to give me 2 squared, which is 4. That equals 25. Then I need to solve that, right? So what do you think I could do to solve it? I think the easiest way to do this would be factor, or is that really what you mean? What do I factor? Do you mean multiply? Okay. Now I could multiply all this out, right? And I could get something that I could then factor is probably what you meant, right? But then if it's not factorable, what would I have to do? Quadratic formula, right? Which is all perfectly legal and perfectly fine, and like you could probably figure all that out on your own. But I'm going to show you something else that actually makes it a little easier, but you got to pay attention to what you're doing here. So instead of doing that, I'm going to go ahead and move this 4 over here, and I'm going to get X minus 3 squared equals what? 21, right? So now I want to get X by itself. Really, that's my goal. My goal isn't necessarily to factor or to do anything. I just need to figure out what X is going to be. So if I'm trying to get X out of all of this stuff, how would I undo this square? I can take the square root of both sides here, right? Totally legal as long as I do everything I'm supposed to do along the way. So that means if I take the square root of both sides here, right, which you can do, then this is going to give me X minus 3 equals what? Here's where we have to be extra careful. Plus or minus. There are 2 answers here, plus or minus the square root of 21, right? So then, when I'm going to go get X by itself, I'm going to move that 3 over, so X, oops, I'm leaning, sorry. So X equals 3 plus or minus the square root of 21. So clearly, I wouldn't have been able to factor that one, right? I would have had to use the quadratic formula, which is fine, but is that a little bit easier than quadratic formula? So that is one way to be able to solve those there. All right, so then I've got X would be 3 plus the square root of 21, comma 0, and 3 minus the square root of 21, comma 0. Then I'm going to go find my Y-intercepts. For the Y-intercepts, I put a 0 in for X, right? So when I put a 0 in there, I get a negative 3 squared, which is 9, right? Plus Y plus 2 squared equals 25. So I'm going to move that over, and this is going to give me Y plus 2 squared equals what? 16. So now I'm going to take the square root of both sides, which will give me Y plus 2 equals what? Plus or minus 4. Yes. Make sure that you don't just put that when you have a square root left, but when you actually take the square root, that's important too. Right? That plus or minus, that's what's going to hurt you here if you don't do it right. So then we get Y equals negative 2 plus or minus 4. Which means that when we go over here to do our Y-intercepts, we have 0, and then negative 2 plus 4 is what? 2, and negative 2 minus 4 is negative 6. So this one, if we'd have multiplied it out, it would have factored and factored fine, but you don't know that until after you do it, and so this will work either way without you having to do anything crazy. If you want to do quadratic formula and all that stuff, that's fine, but here, 4 parts to the answer. We've got the standard form, center and radius, X-intercepts, if there are any, because it's possible that there's none, and then your Y-intercepts. Okay. We all good so far? All right. So this last one. How does this one look different from most of the others we've looked at so far? We have coefficients. We have the x. Oh, shoot, there's no y squared. Dang it! There is a y squared, but it's not squared. Oh. Okay, let me just double check then that that's really the right numbers. I changed it at the last minute, and when things are italicized on there, dang it. I double checked myself 3 times that I had it right. Oh wait, I have it written on the back of this thing. I think I deleted it by accident when I was trying to fix that minus sign. So yeah, so that wouldn't even be a circle, right? No, why is that 4y? No. Okay, this whole term decided to change itself. That should be 2y squared. Make that 2y squared. Then everything else will work out fine. Okay, I didn't like the problem that was there, so I redid it to make sure it would work, and then I typed in the wrong thing. Okay, yes. So now that it's fixed, now how does it look different than the rest of them? The coefficients, yeah, which is what I was going for there. All right, and so we can't have a coefficient. Since the x squared and the y squared have the same coefficient, then that tells you that it's a circle, because we're going to have to decide which conic section we have. But since it has the same one, then that's going to make it a circle, because we don't want one at all. And so I'm going to divide everything through by 2. Okay, and I can start off by doing that, and I got to make sure I do it right. That'll make this x squared plus y squared, then what? Minus 6x plus 2y plus 9. Okay. That's where we want that to be. All right, so now I'm going to let you go through and put this in standard form and find all of your stuff, and then I will work this with you. Okay? Okay, so we're here. Do y'all agree with this much of what I have so far? Yes? That's your standard form. That's your center and your radius. And then we've got to find our intercepts. So if I start with the x-intercepts, it's going to give me x minus 3 squared. And then that's going to be 1 squared, so plus 1 equals 1, right? So then that's going to give me x minus 3 squared equals 0. So what does x equal? 3. X has to be 3. You can take the square root of both sides, but whatever. But the only thing that's going to make this 0 here is putting in a 3. So for my x-intercepts, my only x-intercept is 3, 0. Then I got to find my y-intercepts. So to do that, x is 0. So this is going to give me a negative 3 squared, which is going to give me 9 plus y plus 1 squared equals 1. So then y plus 1 squared equals a negative 8. So when I take the square root of both sides and I get y plus 1 equals the square root, or plus or minus the square root of a negative 8, what's wrong with that? Can't take the square root of a negative number. Well, you really can, right? But what do you get? Imaginary. And so what we're looking here for intercepts, if it's an imaginary number, is there an intercept there? No. So we can get an answer, but I'm not just looking for us to solve for y. I want a y-intercept, and I can't get one here, which means for my y-intercepts, there are none. So this circle is just tangent to the at the point 3, 0. Okay, but it doesn't touch the axes anywhere else. And so then these are my 2 answers for my intercepts. Okay, everybody okay with that? So you can expect to get a none for some of them. You can expect to get pretty decent numbers that aren't so bad, and then you can expect to get some that are square roots. And again, whether you choose to do it this way or you want to multiply it out and then do the quadratic formula or factor it, that is a possibility, but this is why we like to complete the square anyway. Right? We good? Any questions at all? All right, so I know the assignment looks like a packet, but the alternative was not so good.